Hello, Precal. This video is going to be a little bit different because clearly you don't see me, which is honestly probably a good thing at this point of the day. But you will hear me and you'll see me working problems out. I just won't be in front of my smartboard. So don't spend too much time crying over that. We're going to take a look at this last section in chapter 6, and we are still dealing with trigonometry. We've spent a couple days on the law of sines, and now we're looking at the law of cosines. Let's just review for just a moment. Remember, we used the law of sines when we had a triangle that was ASA or AAS. So in other words, we had information about two angles and a side. We also saw the ambiguous case of SSA. We saw that sometimes no triangle is created, sometimes one triangle is created, and sometimes you have two triangles. So what happens if you don't have one of those three cases? Remember, in geometry we learned about SAS and SSS, and that's really where the law of cosines comes in because it will help us. So if you look right up here, you've got three formulas. Basically, if you can memorize the first one, and you do have to memorize it, then the other ones are kind of interchangeable. So over here, what your equation will be equal to. So if you're looking for side A, okay, then you're going to be using angle A over here. If you have side B on the left side of the equal sign, then you're going to be using angle B on the right side of the equal sign. And the same thing happens for C. If you're using little c on the left side of the equal sign, then you're going to use big C on the right side of the equal sign. So if you can manage to just memorize the first one and then interchange, but basically what's happening, so you have a squared equals, then over here you're going to start off by it looking kind of like the Pythagorean theorem. So you're going to have the other two sides that you're going to add their squares, and that happens for all three of these. And then all three of these have minus 2 times whatever these two sides are on the right side of your equation. So for this one, it's B and C. For this next one, it was A and C. For this last one, it was A and B. And then you're multiplying that times cosine of angle A, because that's little a over here, or angle B because that's little b over here, or angle C because that's little c over there. So really, if you can just memorize one of them, it's not going to be too bad. You'll notice that when we did the law of sines, it always gave us an angle value that was in quadrant 1. So we had a small angle measure. And remember, when we did law of sines, we sometimes had to check to see if we got a quadrant 2 answer. Well, when you use the law of cosines, it helps us out because it will find that large angle. So it will potentially give you a quadrant 2 answer, and then you know you've got it, instead of having a quadrant 1 answer and then having to check if a quadrant 2 answer exists. So it says right down there, it says use the law of cosines to find the largest angle, because it will give you either the acute or the obtuse angle. So let's take a look at example number 1. I'm going to move this up a little bit. And it says that the sides of a triangle are 5, 8, and 12. Oh my, just kidding. Can y'all see? Can I see? Okay, one guard, don't do that again. Okay, so you don't have to draw a picture, but I kind of like to know, is this thing shaking? Sorry, y'all. I kind of like to know what information I've been given, which you can tell, but I like pictures, y'all know that. So here I have a triangle. I've got 3 sides. So right now what I have is SSS. So that leads me to believe that I want to use the law of cosines. And so real quick, let me just put that this would have been capital A because little a is across from it. This would have been capital B because little b is across from it. And this would have been capital C. So I think what I'd like to do, because law of cosines says that it will find your largest angle, and clearly angle C has to be my largest angle because it's across from the longest side. So angle C is the largest angle. So that's what I'm going to go with. I'm going to use the formula, the third one, c squared equals a squared plus b squared minus 2ab times cosine of angle C. And now I'm just going to plug stuff in. So I have 12 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of angle C. And now we're going to do some math. So I've got 144 equals 25 plus 64 minus 2 times 5 times 8. That should be 80, I believe. And then times cosine C. So then I'm going to go ahead and say, okay, well, 25 and 64, that would add up to 89. So I'm going to go ahead and move that 89 over, subtract it on over. So 144 minus 89 is 55. So I end up with 55 equals negative 80 times cosine of C. And I need to get cosine of C by itself, so I'm going to divide both sides by negative 80. So now I have 55 divided by negative 80 equals cosine of C. And hopefully you remember, how do I get rid of cosine? Well, we have to inverse cosine on each side. And you definitely need a calculator, so if you don't have it, go ahead and pull one out. It's probably already in degrees, but it's always a good idea to check it out and make sure. Mine is. So I'm doing inverse cosine of 55 divided by negative 80. And I get a quadrant 2 answer. I am getting 133.4 degrees. The thing I love about that is I don't have to worry about, when we did the law of sines, getting an answer and then saying, well, do we have a quadrant 2 answer? Will that work? This one is what it is. So we've got a quadrant 2 answer. And so now we need to find angle A and angle B. And at this point, I'm going to go back to the law of sines. So I have sine of angle C. We just found out angle C is 134, just kidding, 133.4. I'm going to put that over little c, which is 12. And then I'm going to go for A first, just because A comes first in the alphabet. So sine of angle A over little a, which is 5. And now I'm going to cross multiply, and hopefully you guys are getting pretty good at cross multiplying, because I'm just going to go ahead and jump to the step where I've gotten sine A by itself. I feel like this thing is shaking crazy. I'm sorry if it is. And then I need to find angle A. So this is much harder than I thought it was going to be. It moves a whole lot. Sorry, y'all. I'm going to inverse sine on each side. And then I'm going to pull out my handy calculator and punch in some buttons. Oh, and I'm typing it in wrong. So let me try that again. Okay, so inverse sine of 5 times sine of 133.4 over 12. And I'm getting that angle A is approximately 17.6 degrees. And so now I just have to find angle B. So I'm going to go back to my calculator, do 180 minus 133.4 minus 17.6, and I find out that my missing triangle is 29.0. Or missing angle, sorry, not missing triangle. It wasn't missing, that was silly. All right, how do we feel about first example? It's a little tedious, I will agree if that's what you're thinking, but doable. So now let's take a look at example 2. So here's what we've got. We have triangle. Let me just go ahead and label. So I have A, B, C. They gave me angle A. they gave me little b, they gave me side c. So you might recognize this from geometry. This is going to be SAS, side angle side, because the angle is right in between the two sides. I actually already know what the largest angle is because I have an obtuse angle given to me. So I'm going to use the first formula that we had, which is the a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. And now I'm going to plug everything in. So I don't know little a, but I know that b is 4.5, and I know that c is 4.7, and I'm just plugging it in. Very lonely plugging it in. Wish I weren't by myself. And then I'm plugging in 136 for angle A. All right, so guess what you get to do? You get to plug that in just the way that it looks. All of this from here to here, just plug it on into your calculator. So where you see a parentheses, put parentheses. Where you see an exponent, put an exponent. All that fun stuff. I am doing that right now. And I'm getting kind of an ugly answer, and you might be too. I'm gonna write it down, but I'm not actually gonna encourage you to write it down. Let me get it all on this paper. Because I think that you can take this next step with your calculator and not write this down on your paper, but I wanted to show you, just as a reminder, how would you go about getting A by itself? Well, it's pretty easy. You're gonna square root. And remember, we like to include plus or minus, but we're not going to because you can't have a length that is negative. So we're gonna square root that. Now, I wanna square root, I don't want to round this and square root a rounded number. I want to square root exactly what's on my calculator. And I told you guys before how to do that. You want to use the answer. And so depending on what kind of calculator you have, but right above the negative sign on my calculator, it says ANS, which stands for answer. So first I'm going to hit the square root button. Then to get to ANS, I'm going to hit second, and then that negative sign, which now my calculator says ANS for answer. So I'm telling the calculator that I want to square root the answer. Can y'all see that? Hopefully the glare is not too bad, but anyway, I want to square root the answer, and we're going to find out that that measurement is approximately 8.5. So A is approximately 8.5. All right, so we now have a third side. And now I'm just gonna go back to law of sines here. So I've got sine of 136-degree angle over its opposite side, which we just said is approximately 8.5. And I'm gonna set that equal to sine of, I'm gonna go for B first. So sine of angle B over 4.5. And so I'm going to cross multiply, and then I'm going to have to divide both sides by 8.5, and that gets sine of B by itself. But we don't want sine of B, we just want B, so we're going to inverse sine on each side. And now I need my calculator, so inverse sine of that lovely thing on our paper, and I have gotten that angle B is approximately 21.6 degrees. So the last thing that I need is angle C. I'm going to go back to my calculator. 180 degrees in a triangle. I'm going to subtract out the 136 that we already had for angle A, and then I'm going to subtract out the 21.6 that we just got for angle B. And I'm going to find out that angle C is approximately 22.4 degrees. So we have our third missing side and our two missing angles. All right, let's keep going. Next one, So clearly we have SSS, right? SSS. And obviously angle C would need to be the largest because it's across from the longest side. So I already know that I'm going to be using that third formula that was on your paper. And I encourage you to write it down every time. The more you write it, the faster you're going to learn it. So let's see what we have. We have 33 squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times cosine of C. So then we get 1089 equals, what am I doing? Oh no, I'm good, sorry. 64 plus 81 minus 2 times 8 is 16, 16 times 9 is 144, cosine of C. So if you add those together, you're getting 145. So I'm going to subtract that 145 from each side. So 1089 minus 145 is going to leave us with 944 equals negative 144 times cosine of C. And then we're going to divide each side by negative 144. And you guys, I'm sure, remember that now we need to do what? Inverse cosine each side. And let's work out our index finger. Here we go. This is about the only exercise I'm getting lately because the rest of me is eating and gaining weight. But my finger's gonna look good with all this workout. So I've got inverse cosine of 944 over negative 144. And you may see a similar problem. Mine says domain error, which, what do you think that means? That means that no triangle exists. So we see a case of there's not a triangle there. Now, if I take you back to a geometry lesson for just a minute, you might remember in geometry we learned that when you have a triangle, you should always be able to add up two sides, and whatever you get should be greater than the third side. So real quick, if we go back to this last example, if we add up 4.5 and 4.7, that's bigger than 8.5. If we add up 4.7 and 8.5 together, that's bigger than 4.5. And if we added 4.5 and 8.5, that's larger than 4.7. That's how we know that we have a triangle. But if we go down to this one, look what happens. 8 plus 9 is 17. 17 is not bigger than 33. So right away, I know that this is not going to form a triangle. So if you can use some of your geometry skills, you know, you could have avoided a little bit of work. Now, if you didn't have any work, what would I expect to see on your paper? I would expect you to say, no triangle exists because 8 plus 9 is not greater than 33. So if you had something like that, I would know that you know what you're talking about, and that would be perfectly acceptable. All right, let's move on to example number 4. And we have another triangle. So let's see, let me just call A, B, C. Angle B we have is 22 degrees. Little a is 123, little c is 97, and we're missing little b, angle A, and angle C. So this is an excellent example of SAS. Let's see here. So we have angle B, and we have little c and little a. So probably what I would use is the second formula where we're going to look for b squared. And I'm using that one because of the information that they gave us. No, wait, I'm writing the wrong letter down there. I knew something wasn't right. So the reason I chose this one is we have little a, little c, and big B. So all of that's going to be filled in, and that's what we're going to solve for. So we got b squared equals 123 squared plus 97 squared minus 2 times 123 times 97 times cosine of 22 degrees. Again, this is that problem where you can plug everything right on into your calculator, which is exactly what I'm doing right now. Hopefully you are joining with me. And again, I'm getting a crazy looking number, but remember that crazy looking number is not b. It is what b squared equals. So what do? We're gonna square root it. So hopefully you remember how to do that using your calculator answer. We wanna just use that answer button. So again, I'm showing you right here. I'm telling the calculator, I'm gonna just show you how to do it. I'm hitting the square root button. And then I want that A and S right there. So I'm gonna hit second, answer, and the calculator is gonna tell me that little b is approximately 49.1. So there's one answer, and I need 2 more answers, and now I'm just gonna go back to law of sines. Now remember, law of sine is gonna be used for your smaller angles. I'm missing angle A and angle C. Which angle is going to be the smaller one? Angle C is going to be the smaller one because it's across from the 97 instead of the 123. So I'm going to go with that. So first I've got sine of 22 over 49.1. So we had angle B, and we're putting that over little b. And then I just told you guys that we're going to be solving for angle C because it's going to be smaller than angle A. Obviously, my picture is not drawn to scale, but that's okay. Sine of C, and I'm going to put that over 97. So I'm going to cross multiply, and then I'm going to have to divide both sides by 49.1, and that's going to isolate sine of C, and then we're going to inverse sine on each side to get rid of that sine. And so now let's use the calculator. So we're going to inverse sine of 97 times sine of 22 degrees over 49.1. And I am finding out that angle C is approximately 47.7 degrees, which means the last thing that I need to do is find angle A. So again, going back to my calculator, 180 minus the 22 degrees from angle B, and then minus the 47.7 degrees from angle C, and that leaves angle A with being 110.3. Now, just as a reminder, I want to show you, well, not show you, but just kind of talk with you. If you had tried to solve for angle A using the law of sines, you would have gotten a quadrant 1 answer, and that would not have been correct. So that is why I chose to go for angle C, because I knew it had to be smaller than angle A based on the side lengths. So law of sines is going to get you your smaller angles. That's what I was going for. All right, so I think because this video is already kind of going on for a little bit, let me go ahead and stop for just a minute, and then I will do another video for the rest, because sometimes these videos take me a really long time to upload, and I'm worried that the longer I make it, it's going to take too long. So go to the bathroom or get yourself a Coke or a coffee, and I'll see you in a minute.